Welcome to part 4 of my data virtualization series. Today I'm going to complete the Spring Boot data virtualization application by incorporating Keycloak for security control. These are the topics I'm going to cover today. Recap on progress, the Keycloak Operator, demo on setup and configuration of Keycloak, demo on interaction with virtual database and access control. First of all, let us look at our progress so far. In the last video, I showed you how to create a Spring Boot data virtualization application and deploy it on OpenShift. It is not functional yet because we are yet to include the Keycloak integration in there for security control. This is what I'm going to do today. Keycloak lets you add authentication and authorization without writing code. It supports standards like OAuth 2, SAML 2, LDAP, etc. The Keycloak operator is used for installing and managing Keycloak. In the demo, I'll show you how to first of all install the Keycloak operator and then use it to install Keycloak. To configure Keycloak, I'm going to use the Keycloak admin console. It involves the following steps. 1. Create a RAM for your application. A RAM manages a set of users, credentials, roles, and groups. A user belongs to and logs into a RAM. RAMs are isolated from one another and can only manage and authenticate the user that they control. Once a RAM has been created, we can create a Keycloak client. A Keycloak client is an application that wants to use Keycloak to secure itself. In our case, the Spring Boot data virtualization application. Then we're going to create roles for the client. Remember in the last video, I used two different roles. One is called read role, which allows the user having that role to access any one of the virtual tables in the virtual database. The second role I use is called stock role, which only allows users with that particular role to access the stock price virtual table. Then we are going to create users. The last step is to assign roles to users so that their access can be controlled by the permission defined in the role. And this is how Keycloak works with our Spring Boot application to do authentication and authorization. Say the user here wants to access the Spring Boot application using OData, so we put the URL in the browser and hit enter, and the request is sent to our Spring Boot application. Since we have integrated Keycloak with the application, the Spring Boot application will redirect the request to the Keycloak server, which will put up a login page, which the user fills in and send back to the Keycloak server. The server then authenticates the user. If authentication is successful, it will redirect the request back to Spring Boot application. Spring Boot is going to retrieve a token from the Keycloak server, which contains permissions for the user. And then Spring Boot will check the permission and allow or disallow a user to access the resource being requested. Now it's time for a demo. To install an operator, you need to log into OpenShift using an account with cluster admin capability. So let me log in as admin. Let me click on Operator Hub and enter Keycloak. Select it, continue, and click on Install. And you should select the project you wanted to install the operator in. Select DB demo. Because I already installed the operator in that project, it's campaigning now, so I don't have to install it. I'll just show you what it looks like. After a few minutes, it will install the operator. Now let me select the project and select Installed Operator. Click on Keycloak Operator. You see there are a number of tabs here that you can do. For example, create instance. The first time you do it, you should click on Create Instance to create your Keycloak instance. Now you may want to change the name of the instance in here. No, it's just cancel it and look at what I have created. Keycloak db-keycloak. By creating your instance, if it's the first time, it will also install a Postgres database along with it. Now, if you go back to Overview, you can see that you can use the Keycloak operator to do a number of different tasks, like create an instance, create a Keycloak RAM, create a Keycloak backup, Keycloak client, and Keycloak user. But you can do all this using the Keycloak admin console as well. So if you click on networking, routes, Keycloak, the location, and then click on administration console, you can log into the console. As I mentioned earlier, the first thing you want to do is create a new RAM for your Spring Boot application. So click on this here, add RAM, give it a new name. Click on create. Next thing you want to do is to create a client. That is an application you want Keycloak to provide security access. So click on create and give it a name. And you can use any client ID provided it matches the parameters you put into the applications.properties file in the Spring Boot application. Save. This is the important part. Valid redirect URL. This is, if you remember the diagram I showed you, after the Keycloak server authenticated the user, is going to redirect back to the Spring Boot application. So how do you find out about the URL for the Spring Boot application? You have to go back to the networking, routes, and then this is the base URL. So what you should do is you put it like this. So that means any pages after the URL, you click save. The next thing you want to do is create a couple of rows, like add row. Remember, two rows I use in the Spring Boot application. One is called read row. Just click on it. Go back to row. Create another one. Click on Save. Now we have created the realm, a client, and the roles in that client. Now we are going to add a couple of different users. Let's add one called the developer. And then we want to do the role mapping. Developer can only have, say, stock role. And then I want to add another user. And this time I want to add manager, for example. Role mapping. Read role. Now, if you get back to the client, click on Spring Boot. If you click on the installation, select a format, say JSON, you see a number of parameters. So what is the authorization server URL, what is the SSL required external, etc. All this information, if you remember, so it's the same information that you enter here to match the realm and client that you have created. Now I can show you how to interact with the Spring Boot data virtualization application with access control. Let's get back to the OpenShift console. And this is the root for the Spring Boot application. Now we are using the base URL and add all data, portfolio, stock price, IBM, etc. in there. It appears that after upgrading to a new version of Chrome, I'm no longer able to access sites using self-signed certificate. Instead of resolving that right now, let me just use another browser. It's Firefox. Now let me log in as developer. It's giving me the current price of the stock IBM. So if you think it's too verbal to use XML, what you can do is you can add JSON in there. And you get a JSON representation of the whole thing. Now in my application, I have assigned stock role to developer. So that means I cannot use it to access any other virtual table. So if I use it to access the account values virtual table, so this is what it gets. It cannot access it. Now let's log in with another credential. This time we're using a user with a role called read role. That means it can access everything in the virtual database. Start a new private window. Let's execute the same thing first. This time I'm logging in as user. So it's giving me the same answer, so I change it to JSON format. Let's try another virtual table. This time I'm going to access the account values virtual table. Remember, when I log in as developer, I cannot access this particular virtual table. Now, success. So this is a demonstration of how access control can be achieved using Keycloak when you're accessing the Spring Boot data virtualization application using OData. Next, I'm going to show you how to access the virtual database using JDBC. First of all, I have to make sure that I log into OpenShift and is in the dv-demo project. Then I'm going to port forward the Spring Boot applications port 31,000, which is the virtual database access. So if I log in as developer, let's have a look at the setup here. Right? I'm logging in as a developer, and I'm using this particular URL to access the virtual database. Let's log in. Now, if I try to access this particular virtual table, customer holdings, I cannot, because the role forbids me to access that particular virtual table. But if I access stock price virtual table, I succeeded. Right? This again demonstrates that access control was achieved using a combination of Keycloak and the virtual database. Now let us log out of here. And log in as another user. This time I'm going to use a user with role read role. That means it can access all virtual tables. Connect. Now let me just run this. Obviously this one will work, but I can also access some other tables as well. Customer holdings table. This shows that this particular person owns 2 stocks, Dell and TM, and these are their current prices. Let's look at another one. Now, it's the same person. This particular virtual table just total up all his holdings here, which is over $5,000. I hope that shows you how access control is achieved using Keycloak. Here is a summary of my data virtualization series. In the series, I explained what data virtualization is, and I stated a number of use cases and then implemented those use cases using 2 different methods. 1 by using the data virtualization operator, and 2 by using Spring Boot. And then I incorporated Keycloak into the Spring Boot application for access control, and then show you how to interact with the virtual database and how access control works. Now, armed with the basics, you can now set out on your own to explore on the more advanced topics, including materialization of virtual tables in a cache and in memory cache. Good candidates for materialization are virtual tables which are changing really slowly but accessed very frequently. And you can also explore column masking. For example, you have sensitive information, You want users to be able to access that particular table, but you don't want them to see certain fields. You can use column masking for that. In this series, I only show you how to use two different data sources that are supported out of the box, namely a relational database and a REST service. You can explore all the other supported data sources on your own. The data virtualization operator only works on OpenShift. But by using Spring Boot, you can use it outside of OpenShift itself. And that is a third way of creating a virtual database. That is by using Fields Online, which is a citizen integration tool. For those who know, there is a sunset product called the JBoss Data Virtualization Server. If you happen to be using that server and you want to migrate the virtual databases created using that product to run on the current platform, you can do that as well. Happy exploration and experimentation. Thank you for watching this series.